Okay, okay, the audio should be working again. So yeah, okay, hello everyone, and yeah, this is the fifth technology dive stream. This stream also marks the first monthversary of my VTuber project here. So yeah, thank you to everyone who has watched my content so far. But for my first monthversary, I am not going with anything special. But if anything, circumstances kind of forced me into this 7 day a week stream schedule. Yeah, this was kind of forced real life circumstances. Like, the, yeah, by real life circumstances, I mean, yeah, a lot of game events that I am looking forward to. Like this week, there's so much that I am looking forward to. Okay, let's just. Oh wow, there. Okay, I guess that Explorer pop up in the wrong place. But yeah, let me show you a bit of the schedule here. This week is absolutely packed because of a lot of things. Yeah, today is obviously today is the technology dev stream there. The tour of Go, and then we have tomorrow we have Punishing Grey Raven. I am continuing to try out the game, and then another Art Night stream, and then I am going to install Windows 7 because July 22nd turns out is the RTM release date of Windows 7, and then the next day Azerlane because of a collaboration event between Azerlane and Idolmaster of all series. And then for Saturday is the usual visual 3 stream, and just to complete the 7 day a week stream schedule, I am going to be streaming on Sunday, something that I have never done before. For Sunday, I will be streaming Genshin Impact, just a regular farming stream, I guess, while exploring stuff. I actually do not know if the Inazuma region will be released around that time. Oh, okay. July 21st. Okay. Okay. Yeah. So I am completely not aware of the 2.0 update. And so yeah, this Genshin stream will be also be exploring Inazuma, I guess. So that's pretty neat. But alright, enough talk about schedule. Let's dive right into today's stream, which is yeah, about Go. The programming language, you know, yeah, I will be using the tour of Go to be, you know, learning Go today. So today's presentation is a bit short, and most of the presentation that I do will be on the tour of Go website itself. So yeah, let's go right into it. Yeah, yeah. First of all, yeah, the Go programming language is designed at Google. Go figure. Yeah. And then I see a lot of Go used from simple web applications to enterprise grade orchestration software. Like I see a lot of those self-hosted applications being written in Go. And then did you know that Docker and Kubernetes among those enterprise grade container software is written in Go. Yeah, Go is used in a lot of places. Then I have used the language before. I have actually written an application with Go, and I think it's in my report. Yeah, I think it's my in my GitHub. I think two of them, in fact. Okay, yeah, this is something that I wrote in Go, the programming language a while ago, and it's basically just a Bootstrap-like software written in Go as the back end and Svelte GS as the front end. Uh, Interesting. Yeah, this is my first time looking at Go. Yeah, I used it before and it's pretty cool. Yeah, but today I will be going to the tour that the Go project provided and see some stuff regarding Go. Yeah, it's pretty much just a pet project of mine. Yeah, but yeah, what's wrong with revisiting the tour itself again? Then yeah, okay, there's uh, uh oops, I guess. Yeah, those are like the three main features that I like from the Go programming language. First of all, Go is a compiled language. There's like no overhead of interpretation like the usual web backend programming languages. Like the one of the most popular programming language for websites, for easy web hosting and stuff is PHP, and PHP is a kind of an interpreted language by its classification, and then also things like JavaScript, which is also used on the server as Node.js. Yeah, Go is compiled, and that means that it's able to do things faster than the the most popular web programming languages because yeah, it compiles into machine language and you can directly run it on the computer. And then Go has quite great cross compiling support for Windows, Linux, and Mac OS and more. In Go, it is really easy to build Windows executables for Linux, for example. Like I think you need to set two environment variables to be able to build Windows executables on Linux. And yeah, that's why if you see projects written in Go, in, for example, like Kubernetes, you are able to see that they provide binaries in like Windows, Linux, Mac OS, and most other language don't like most other language probably doesn't do that from what I see. But yeah, you can write Go code and then run it in basically all of the major platforms, and it's compiled. Pretty neat. And then yeah, Go also has concurrency features that see is very interesting. I have not used them, but I think we're going to visit it on the stream as part of the tour of Go. So yeah, let's see. And yeah, about the tool itself, it's from the Go project itself. It's at tor.golang.org, and it covers the basics of the languages and also some important concepts on Go programming, like the concurrency features that I mentioned earlier. So yeah, just go. Let's learn Go together. Okay, yeah. And I see I have not changed this. So yeah, okay. I have not changed the title here. Kind of forgot there. I was quite busy today. Okay, let me see. Okay, where is the correct Firefox for this? Okay, yep. Let's simply just do this, I guess. Uh, this has just gotten worse, isn't it? Minutes into the into the stream, and it's disabled again. Yeah, this is starting to look a bit anno- this is starting to look a bit annoying. I will need to think of a solution again here. So okay, let me just continue here because okay. And then run and waiting for remote server, and then you can see that this is like running right now. Okay, I will actually check out the running stream right now because yeah, this is not pleasant, and I really wish that I don't have to private this stream again. Let's hope that the this sound missing problem is not really annoying right now. So yeah, let me check for a while. I mean, like, and oh, this has just gotten worse, isn't it? Don't have to private this stream again. Let's hope that the your voice is fine now. Don't worry. Okay. Yeah, it is fine now, but I really don't want this to glitch again in like 20 minutes again. I might need to check a thing of two after the stream because I'm not liking how this goes. Like, not at all. Okay, yeah. So yeah, I basically try out the Go programming language here, and then let's click next. The tour is available in other languages, like there's even Indonesian. That's interesting. And then there's also okay, there's also the Japanese version if that is your thing. Hello Sekai programming. Yeah, like yeah. It is translated into Japanese and also Indonesian if that's your thing. Okay, okay, let's click next again. Go offline. Optional. And yeah, you can actually run this as a standalone program. I will continue to take the tour to this website because this is not this machine that I'm streaming from does not have Go unless I'm using the Linux virtual machine. And then yeah, this is the Go Playground. This store is built atop the Go Playground as a web service that runs on golang.org servers. There are limitations to the program that can be run in the playground. In the playground, the time begins at 2009 11 10, 10 November 2009. Determining the significance of this date is an exercise for the reader. I think the I think it's the Go initial release date, right? Yeah, it is the Go initial release date. That's why they use this. Nice. This makes it easier to catch programs by giving them deterministic output. There are also limits on execution time and on CPU and memory usage, and the program cannot access external network hosts. Yeah, congratulations, you finished the first module of the tour. Let's go to the next lesson. Packages. So yeah, every Go program is made up of packages, and they start running in the main package here. And the program is using like two packages here, the FMT for formatting and mat/ran for random. Yeah, okay. Yeah. Okay, so the environment in which these programs are executed is deterministic. So yeah, so each time you run the program here, the random.intent and here will return the same number. Yeah, just a little bit of detail here. You can probably change it like let's say this one. My favorite number is 1. My favorite number is 2. Okay? Imports. This code groups the imports into a parenthesized factored import statement. You can also write like multiple import statements too. Like for example, if you want to do this, entirely possible. And then for exported names here, yeah, the name is exported if it begins with a capital letter. Okay, I turned off the BGM previously here, but yeah, okay. For example, pizza is an exported name as in pie with uppercase. Yeah, the difference between public and private names is like the name and only the name. yeah, yeah, Go is quite simple right there. Yeah, you don't need to add like public or private keywords. You just need to ensure like it starts with a uppercase or lowercase letter to make it public or private respectively. And then yeah, a function, it can take like 0 or more arguments. And then yeah, so unlike other programming languages that you probably see, like yeah, C, unlike programming language like C, the type here goes after the variable name. So instead of typing integer x, you write x integer. So if you run this one, it will add the numbers 55. When two or more consecutive name function parameters share a type, you can omit the type from all but the last. So yeah, if you like go everything is an int, you can just write like this. Very neat. And then yeah, a function can also return multiple results. This is a pattern that you will see a lot when programming in Go in real life. Because one of the things that often use this multiple results pattern is Go's error handling. I don't know if it is demonstrated here, but if they don't demonstrate it in the tour, I will probably cover it by myself. I showed it? Okay. Don't know. But yeah, a Go function can return multiple results. Like if we run this, hello world, it becomes world hello. Okay, Go's return value may be name. Okay, I actually don't know this. I have not used this often, but yeah, you can name the return values here. Yeah, you can return two values and then name them here. And then there is something here that we return without arguments, just return those two values here. Yeah, this is interesting. Yeah, also this is something that you will see a lot. Okay, variable declaration. Yeah, you use the for keyword here, and again, just like in the function declaration, you see the type is defined after the variable name, and you can like normal variables, you can define them at the package level here or on the function level. So yeah, pretty neat. And then yeah, you can initialize it with like this. Yeah, but I think there's another syntax that you can do. You can create and declare the variable with this shorthand colon equal. And then you can, okay, let me just put this here to experiment here. And then print the variable here. Let's see if it prints. Okay, yeah, it prints just fine. Yeah, so this might need some, getting used to, but if you just want to assign and the variable is already declared, this is fine. I kind of just, muscle memory. Okay, so when I define, you can define the variable at the beginning and then assign it later. You can, you can also assign with that syntax only slightly longer here. But you can also do it the quick way with with colon and equal sign here. So like this. So this equal sign is for assigning to a variable that is already declared, and this one will declare and assign the variable. And then the basic types of the Go programming language is, you probably have seen this in other programming languages, but yeah, there's boolean, there's string, there's the various integer sizes, there's a byte, there's a rune, yeah, for Unicode code points, float numbers, and there are complex numbers which I don't know what is the purpose of yet. The UIN and UIN-PTR types are usually 32 bits wide on 32-bit systems and 64 bits wide on 64-bit systems. When you need an integer value, you should use int unless you have a specific reason to use a size or unsigned integer type. Okay. So yeah, you can see here in the print here. Okay, there is actually you can print the type here with this format string. Yeah, so let's run it, and you can see type bool value false. You in 64, and then you get this. And then for complex value, look at this, imaginary numbers, pretty interesting. And then 0 values, this is the initial values. So like 0 for numbers, and then false for boolean, and the empty string for strings. So if you declare this without value here, and then for method.printf, you can see all the default values: integer 0, float 64 0, bool false, and string empty. Type conversions in Go looks like it looks like a function call actually. So if you want to convert, for example, a float to integer, you call the type name like a function here. Quite interesting. So you convert to the u integer type here. And then when you run it, you can see this, 3, 4, and then it basically is square root, the Pythagoras equation here. And then Golang is able to infer the type from the value assigned. So if I do the 42, I think it will be integer. Let's change it to something with a comma, and then we got float, and then let's do something false, and then we got bool. Okay, let me see if this works. In 32, oh okay, characters are in 32 because I guess Unicode. And then a string here and we should see string. And then you can actually do complex numbers, imaginary numbers, and then yeah, you see this complex 1 to 8. Nice one. And then constant. Yeah, for constant you just use the const keyword, and you like yeah, you cannot declare and assign it. You must just use the assign it syntax, not the declare and assign for constants, I guess. And then numeric constants takes the type needed by its context. So yeah. Let me see. Overflows integer. Yeah. And then yeah, the Go basics, we did it. And then the main control functions here, the flow control statements for, if, else, switch, and defer. The for loop here is like the C ones, but without brackets. And okay, so you must actually use the brackets here, and you can just you can use no parentheses here. Okay, yeah, 45. Okay, yeah, 45. 1 to 9 being sum. Test. Okay, yeah. And then just like in C, you can you can actually omit this. And yeah, just run like just run like a user program here, and okay, it should be a user program. And yeah, if you only have this thing, the conditions, yeah, if you only have the condition, you can drop the semicolon and it basically becomes while. So yeah, pretty neat, I guess. And then if you just remove all of the conditions and just with a blank for statement here, it will run forever. This is the infinite loop of Go. Timeout running program. It's an infinite loop. What did you expect? This is an infinite loop. So yeah, of course it does that. And then like with for, you can omit the parentheses. So unlike C, you don't need the parentheses, but you absolutely require the braces. Oh, and then yeah, like with for you can apparently declare a variable on the if section, so that's interesting. And yeah, this variable is only scoped to the if block. Quite interesting to see. If you want to return like this, you cannot because it's undefined now. And then you can call else too, like usual. Exercise loops and functions. Now I have to actually code here. As a way to play with functions and loops, let's implement a square root function. Given a number x, we want to find the number z for which z squared is most nearly x. Computers typically compute the square root of x using a loop. Starting with some guess z, we can adjust z based on how close z squared is to x, producing a better guess. Repeating this adjustment makes the guess better and better until we reach the answer that is as close as to the actual square root as can be. Implement this in the function square root provided. Okay, like this. And then let's define a let's define a new variable here. Okay, let's see if I can implement this here. Okay, let's start with a loop and define a variable inside of the for loop. And then do an if. And then compare an inequality and then assign it if it's not equal. Actually, let's do this. Can we do this? If we can do this, this is going to be very interesting. Let's see if I can actually run this. Expected boolean or range effect expression found assignment. Okay, let's test this one by formatting. Okay, the format is working, so let's return invalid operation. Oh, yeah, invalid operation. E declared but not used. Oh, alright, I forgot that I used the assignment here. Let's see. Timeout running program. Okay, yeah, I looks like that I'm still quite That's some bit of thinking here. Let's see if I can run this one. Okay, it's apparently still running somehow. So yeah, timeout running program. Okay, might need to. Okay, I forgot that oh, okay. Okay, 0.5 is apparently still like, yeah. It actually got really close to the correct estimate, but it kept looping between zero, like, yeah, between a small amount. So let's implement that. And then copy this exact value to there. Okay, reduce one more, I guess. Increase it by a little bit. Let's debug the difference finding. Okay, this is quite the roadblock actually, yeah. How do I compare this without like going to something like this? Okay, floating point is fun. Floating point is really fun. Okay, it actually finally arrived at the correct one. Let's remove those. Let's remove this. Okay. When if you got 3, okay. And then 4, yeah, it arrived at the exactly right one. The exactly right step. Okay, so that's nice. Okay, I'm actually going to check this terminal. Okay, yeah. I finally did it. Very nice. Yeah. This is basically a re-implementation of the Newton method. And then the classic switch statement to write a sequence of if else. You know, it's actually like the usual one. And yeah, actually, like, yeah, they say that Go doesn't need to use break. And then it's a simple comparison here, like you can use strings. And the switch cases actually do not need to be constants. You can actually use variables. Interesting. Now that's simple. Yeah. This is like, yes, the switch is a tad simpler than, C and the like. And then evaluation order is like from top to bottom. When Saturday, too far away. Time in the Go playground always appears to start at this particular date because, yeah, of course, they're going to use that date. And then switch without a condition is same as switch to. Yeah, you can actually write switch statements without a variable there. So yeah, for the cases, you can actually do comparisons inside of the cases. What the? You can actually just write comparisons directly on the switch cases. That's really neat. And then default is basically just, okay, just run this at the end of the function. Default functions calls are pushed into a stack. When a function returns, its default calls are executed in last in, first out order. So this should be like 9876546. Yeah, 98765443110. Yep. And we just finished the flow control statements. Pretty neat. And then we have more types. Go has pointers. And yeah, pointers are exactly what you will think of it is as. It's a memory. It's the pointer to a memory address. Usual stuff. Fortunately or unfortunately, you cannot use pointer arithmetic. Like you cannot just add or remove, add or subtract the pointer values. Props to safety, I guess, for Go, the programming language. And then a stock is exactly what we think it is. It's like a stock in other programming languages. It's a collection of fields. And then stock fields are accessed using a dot. And then stock fields, yeah, can be accessed to stock. Yeah. To access the field of X of the stock, when we have the stock pointer, we could write like, reference the pointer first here, but yeah, you can convert it into a pointer and you can just actually call it with the dot notation without the reference. That's nice. The stock literal denotes a newly allocated stock value by listing the values of its fields. Pretty nice. Yeah, you can actually just assign some of the variables using this syntax. And the order is apparently irrelevant. And then yeah, here this is you can get a pointer here with this syntax as usual. And then here you have an array. And yeah, Go arrays are probably like C arrays in which they are fixed length. So if you like, you know, you can define a dynamically resized array, but yeah, there is actually another type that looks like a dynamically typed array. Let's see, slices. So a slice is just a slice of the array. So yeah, like most, like this is probably what you will be working with most of the time with slices, which are dynamically sized rather than arrays. This is the syntax for slicing. So if I change this to 1 and 2, and then it will only get this. Okay, so the slice syntax here is kind of confusing at the beginning. The Go programming language, I think, is 0 index for the arrays. So yeah. Okay, so the first number here determines the first element that will be taken by the slice here. So 1 means I will be taking this 3 at the beginning. Nah, the 2 here is basically, okay, the slice will be just before this element. So if, for example, I just put 1 and 3, it will start from 1 and then it continues to 2, but it doesn't take 3, so the elements will be like 3 and 5. A more intuitive way of imagining it is with a like, let me put a pane in here. And think of it like this. Okay, that is slightly okay, that's just slightly, slightly off the lines, but yeah. So okay, this is a quite smaller number here. Okay, so no, not that one. Okay, so like it will be something like this. Just imagine it as something like this for the slice parameters here. This analogy is something that I've used before, but yeah, this also explains how to think of the slices syntax here. So if you pick from 1 to 3 in the slice, then what you will do is you will take from this and this. So it includes the second and third element here. 1, 2, 3. So it includes 1 and 2. If I, for example, take 4, 7, you will take 4, 5, and 6, the ones between this and this. Okay. I do have the cursor turned off here, so yeah. Okay, let's not save this one. Yeah, slices are like references to arrays. So if you take an array and then you take a slice and then you change something in the slice, and then what happens is that the array is changed, and then when you see everything in the the array changes, so the slice will also change. So like this. John, Paul, George, Ringo. Isn't this the Beatles? Aha. Yeah. Very nice. Very nice. And then yeah, you take a slice and they share the same element here. And then you change the first element of B here. Because it's a slice to an array, the underlying array gets changed too. And then when you see the slice A, which does share the same element as the B we here, then it also gets changed. And then when you print the array, the array also changes. So you can see this one becomes XXX. And then slice literals. A slice literal is like an array literal without the length. So yeah, you can actually like build a slice like this. Yeah, this is basically how you define dynamically typed lists on Go. Yeah. Then you just create a slice and put the elements here. So it actually feels like you're making a dynamically typed array, but it is not a technically it is not a dynamically typed array, it is a slice. This is one of the like mind blowers here in Go, but yeah. You can actually make a slice without actually like you can make a slice and it looks like you just made a dynamically typed array, but it's not. It is a slice. And then when slicing, you may omit the high or low bounds to use the defaults instead. So yeah, if you omit the first, it will take the very beginning. If you omit the second one, it will take the very end. Okay, a slice has both a length and a capacity. The length of the slice is the number of elements it contains. Yeah, and the capacity is the number of elements in the underlying array, counting from the first element in the slice. Okay, this actually makes me think of lists in like .NET and Java, which are backed by a fixed length array. They also have both a length, that is the current number of elements in the list, and a capacity, which is the size of the underlying array of the list. So yeah, the slice also has that two properties too. So it's basically like a Go list here. And then you can extend a slice length by reslicing it, provided it has sufficient capacity. Interesting. Okay, if I just extend it to a very long one, and then it will panic. Runtime error. Slice bounds out of range. The zero value of a slice is nil. A nil slice has a length and a capacity of 0 and has no underlying array. Interesting. Panics cat. Yep. Slice is a slice is not really a an actual dynamically sized array there, but Yeah, if you try to extend it past the underlying array, it will error out. And then here you can make a slice with the make function. You can just specify the length of the slice with make, and you can actually specify the both the actual length and the capacity, so you can add things. And then a multi-dimensional slice, which is just slices of slices. A two-dimensional slice. Nice. And then here, yeah, appending to a slice. So to add new elements to a slice, you can use the built-in append function from Go. And it is quite seamless because if the underlying slice is, if the slice is like too small, the underlying array is too small, it will automatically allocate a new array. So like if you do appends here to add a new element to the slice, it literally works like a list, and you don't really see that, you know, a new array is allocated here. You just see that, oh, there are new elements on the slice here. It increases, but yeah, append is pretty seamless here. And then the range function. Yeah, not the function, but so if you want to do an equivalent of the for each loop in Go, you use the range form here. So you create two new variables. This is for the, yeah, this is the index of the value, and then this is the value itself, I and v. So yeah, Go's for each actually also counts the index. So you're like, if for in other programming languages, a lot of other programming languages that I see, if you want to iterate to a list and you need the index too, well, you are basically forced to use a for loop with the numbers. But in Go, you can actually get the index at the same time as the value, so that is pretty neat. Thank you, multiple return values. Yeah, if you want to ignore the index, just use underscore here. I think this actually works if you want to ignore some of the values returned here. You just use the underscore here. Implement peg. It should return a slice of the line dy, each element of it which is a slice of dx8 unsigned pig integers. When you run the program, it will display your picture, interpreting the integers as grayscale, while blue scale values. The choice is up to you. Okay. Okay, that's okay. We created a okay unit. Very easy to make that mistake. And then loop. then assign the v to a new one, I guess. Oh, okay. I actually just assigned the index here. Let's see if I can run this thing. Cannot use type x plus y divided by 2 type in as type u in a. Okay, as easy as to fix as using the flex type there. Just use the type conversion. You declared but not use. I used it. What do you mean? Do I have to use this? Hmm. Do I have to do this and just ignore this value? Okay, okay, this is okay. I totally just don't use the I don't really need to undefined fee. Okay, yeah, that happens. Okay, that is freaky. That is also straight up freaky there. Let's actually just x minus y and then yeah, it just looks like this. X plus y and then yeah. Must be a divide by 0 problem here? Yeah. Divide by 0. Okay, and then maps. So yeah, a map here maps keys to values, like you probably heard of like the dictionary type in .NET, for example. It it is something like that. Map literals are like stock literals, but the keys are required. Yeah, so like this, perhaps, yeah. When I run it and will print something like this, map. If the top level type is just a type name, you can omit it from the elements of the literal, like this, yeah. Mutating maps. Insert of update an element in map M. Yeah, this is like the usual stuff, I think. Okay, yeah, just you can manipulate the maps values here. Yeah. So, okay, this is, the multiple return types here are used for things like this. The first value is the value of itself, and then the second return value here can be used if to see if the element actually exists or not. Pretty neat. This also indicates an error value. So like if like error or something, yeah. And then exercise maps, implement word count. String dot fields. Okay, I'm defining a variable whose name is totally because of totally defined as a obscure reference to something. Yeah. Okay, let's create a map, I guess. And then the string map here, I will be going to be using strings.fields. This function. Oh, like this. And then we can do this. Okay, let's format if there are no syntax errors there. Nice. Undefined strings. Yeah, import it. Missing return at the end of function. I forgot to run this thing. I return to run it. I am learning Go, and then count of each word not land. Okay, everything passed nicely. Let's next. Function values. Functions are values too. They can be passed around just like other values. So yeah, you can actually return a function in Go, which I saw this before in like JavaScript. And to think that it is possible to do, like, to think that it is possible to do in a compiled language like Go is pretty mind-blowing, to say the least. This is compiled, mind you. This is a compiled language, and you can do this. Pretty impressive. Go functions may be closures, and a closure is a function that references variables from outside its body. The function may access and assign to the reference variables. In this sense, the function is bound to the variables. So for example, the adder function returns a closure. So a closure is basically like a function value, but it references another some variable here. So if you do this, the results are going to be different like this, because each of these has their own some value. Fibonacci closures. Okay. Okay, can we actually optimize this or something? Can I use function literal as type function in, okay, forgot to do the return argument there. And yeah, it kind of returned the Fibonacci numbers. Pretty nice, I guess. And then yeah, we finished this lesson. You can go back to the list of modules to find what's next and continue with the next lesson, methods. Okay, good luck to me actually in this one. Go does not have classes. However, you can define methods on types. So yeah, this is like one of the key differences between Go and most other object in quotes-oriented programming languages. That you can define a method that can have a special, what they call a special receiver argument in here. So yeah, you can actually just reference this. You can reference this on the function, and then you can actually call it like it's an actual function of the struct itself. So yeah, you define this function, and then you can actually call it like it was an actual function of the struct. Very interesting. Remember, a method is just a function with a receiver argument, so yeah. This is basically just like the previous one, but it is a regular parameter, regular argument instead of a receiver argument. And then you can define on, like, even if it's not struct, you can actually do this on primitive types. Like, but however, you have to define the float64 type in here, because you cannot use the built-in types for this. And then pointer receivers, you can declare methods with pointer receivers. This So yeah, what it gets is the pointer instead of the stock itself. Very interesting. Okay, and then pointers and functions. Yeah, we are basically rewriting it as the I gotta go back to work. Yeah, thank you. Yeah, thank you for watching this. Yeah, have a nice day at your work. Thanks for the insight. I'll make sure to check this out. Yeah, thank you. So yeah, this is a regular function, and then yeah, if I change this one, this will not, will not work. Perhaps, let's see. Yeah, I have to change this one too. Okay. Methods and pointer indirection. Okay, yeah. So this is quite of a benefit here. Go actually just simplifies the syntax here. If you have a pointer receiver and you call the function directly with this, it will automatically give the pointer to the function here. Very neat. And then the reverse happens. Okay, so yeah, if you give a value, okay, how do I say it? Jody Setiawan, hello, yeah, hello, welcome to the stream. I'm currently going to this tour of Go, in which I am learning about the programming language Go and the syntax here, and I'm currently talking about method and pointer indirection. So okay, let me continue this. Yeah, if you make a function with a value receiver here, you can actually pass both a normal value and a pointer, and it will automatically resolve it to the correct types. So this is really interesting. The Go programming languages. Okay, and then choosing a value or pointer receiver. Yeah, the difference is like the value receiver operates like on a copy of the value, and this one operates directly on the object on the object itself. So yeah, if you okay, yeah. In general, all methods on a given type should have either value or pointer receivers, but not a mixture of both. Okay, so an interface type is defined as a set of interface method signatures. So this is basically the equivalent of an abstract class here, or yeah, like interface. A value of interface type can hold any value that implements those methods. So it's more like a TypeScript interface if it talks, walks, and if it talks and walks like a duck, it might be a duck. Okay. I need to repeat that more clearly. If it talks and walks like a duck, it should be a duck. Oh, okay. And then they are implemented implicitly. Right. This is probably actually like, yeah, the Java TypeScript, not JavaScript, TypeScript interfaces in which you only need to just implement the functions defined in the interface, and you don't actually need to like implement an interface here. It's just like in TypeScript. If it talks and walks like a duck, it should be a duck, you know. Yeah, and then under the hood, okay, interface values. Under the hood, interface values can be thought of as a tuple of a value and a concrete type. Okay. So it has, yeah, interface values have the actual value itself and the underlying concrete type here. So yeah. Okay. And then interface value with nil underlying values. Okay, if the concrete value inside the interface itself is nil, the method will be called with a nil receiver. Okay. In some languages, this will trigger a null pointer exception, but in Go, it is common to write methods that gracefully handle being called with a nil receiver, as with the method M with this example. Note that an interface value that holds a nil concrete value is itself non-nil. So yeah, you can actually, okay, this is a nil value, and then you can actually assign the interface with nil. And then when you describe here, and then you try to call it, yeah, it actually works on nil. Yeah. Okay, this is actually something that I am confused about, because when we talk about nil, things just start getting out of hand. Ouch. Okay, it's fine. All is fine. A nil interface value holds neither value or nor concrete type, so yeah. It's like, it's very, oops, you good, lol. Yeah, I am fine. It's just, okay, things should be fine. Okay, if you just declare an interface directly, it is a nil interface value, and if you describe it, it will be null, and then it will error out invalid memory address or nil pointer dereference. However, if you put it like this, it will still run, because this is basically a nil. Yeah, it is an interface that has a type but has no value, so it still runs. But in this one, this is a nil interface. It does not have anything. It does not even have an underlying type. So when you call this, it will error out. And then the empty interface, it may hold values of any type. Yeah, this is the probably the object equivalent of the, yeah, in Go. The object equivalent in Go is like this empty interface. Type assertion. Yeah, this is basically the typecasting for interfaces. So for basic types, you can do with just calling it like a function. But for complex types like this interface, yeah, for interface types, to convert it to the underlying value, you have to use this the type assertion, which does look like a function access call here, function access call here with the dot. And then a type switch is a construct that permits several type assertions in a series. Wow, this is actually like, yeah, this is like a type of comparison in JavaScript where you can switch based on the type. Like if the type is int and then it does this, and then if strings it does this, and then default it just, yeah, I don't know about this type. So yeah, this is the type of switch equivalent in Go here. Okay, let's next. One of the most ubiquitous interface is stringer, defined by the format package. So if it can be turned into string, the format, yeah, if it can, yeah, if you implement this string function, then the print in format can print it. So if you, for example, you define this and then you define a string function, yeah, you can actually print len here. So for example, this Arthur Dan 42 years, Safford Bibelbrox 99,001 years. Yeah, this is basically just a type that can be converted to string. Okay, let's implement a stringer function. Okay, let's do this. Let's implement this one. IP address string, and then yeah, we can return it just like as with sprintf here. And then okay, I might actually need to refer to the previous one. Okay, value, and then you do it like this. This is very simple, and I think it does have a security vulnerability. It is, yeah, this is a very nice implementation. Too many arguments to return. Oh yeah, forgot to do that. And then you have this. Nice, I guess, but this is not, yeah. Go programs express error state with error values. So yeah, this is actually one of the parts where, yeah, multiple return values are often used in Go, that is error handling. So when functions, okay, when functions return an error value, they usually return it like this: value and error. And then what they return is an error interface with a error function. Yeah, it did not work. You can actually define your own error. Just implement the error function. Pretty neat. Okay, we can actually return this. Okay, and then we do a check. We do a check here, and then we create a new error type, and then make it an error by implementing an error function. and then let's return or cannot sqrt negative number, and then the value itself, and then let's print it. And then for this one, let's return like 0, and the error itself, how do I, okay, error negative sqrt, and then the x itself. Let's see if it can run. Expected declaration font if I forgot to opening braces. Is this your first time learning Go? This is the first time that I go to a full run of the tour of Go. I actually have used Go before. I talked about it earlier in the stream, but oh, okay, okay, yeah, okay, autocomplete secrets, but yeah, okay. Wait, is the sorry, just new to here. Yeah, it's okay. It's like at the beginning of the stream too. So yeah, I understand. Okay, okay. Why I just laugh because there's this autocomplete just dame. Okay, yeah. I could probably navigate to here. Yeah. This is safer. This is much more safer. Dame nano yo. Antaga. Okay, I should have stopped singing Bagamita there. Okay, let's focus. Let's focus on this. Yeah. So this is a software that I wrote in the Go programming language. It's a simple border software which I cannot show right now because my private instance has a lot of images that may not be suitable for this stream. So yeah, I also do not have screenshots of it. So for now, tough luck. I'm not showing it on stream right now, but yeah, if you want to run it on your server, you can use like Docker here. I maintain a Docker image. Oh, okay. Understandable, yeah, like this. Yeah, okay. Actually, this is just going much further into this territory. Okay, let's continue. Invalid composite literal type error negatives sqrt. Let's actually return. Hmm. Is this possible? It is possible, yeah. Okay, program exited status 137. RAM? Okay, yeah, it finally does. And then yeah, those are other interfaces. This is the IO reader interface. I'm not going to just talk about it for long. But Okay, we have actually to implement the width type. Got byte 0 at offset 0, 1A. Okay, let me check this one. Oh, okay, yeah. Okay, I have to assign it. Fine, fine. I have to assign it. Fine, okay, fine, I guess. What does the in function do? Okay, what does the in return value do? Oh, okay. Okay, nice. Rot 13 reader. Okay, let's create a function. And then return this. And then what we will do is that we read bytes from the reader that they provided. And then we just do a for loop in here. Yeah, okay, let's do this. One variable, but it returns two values. I don't care about the second value. Can arrange byte over bytes type in return address. Okay, return len b error nil. Okay. Cannot range over bytes type int. Oh, okay. I have to actually kind of do this. Okay. Oh, okay. Yeah. Can I use I plus 13 type in as type byte and assignment? So yeah, let's convert it to byte. Output too large. Okay, output too large. Okay. Okay, yeah. Okay, this is kind of going sideways here. Output too large. Go build failed. Hmm. Okay. Yeah, I am a bit confused in here. Let's make it from scratch. Timeout running program. Or it might be an infinite loop. Let's actually differentiate it. Timeout running program. Okay, what is wrong with this one? Okay. Yeah, I have no idea on this one. Like the end result is not easy to debug. Like, what do you mean? Timeout running program? What is it run? What is it running? I only return this. And it time out. And if I do this, what happens? Output too large, I think. Output too large. Okay, this is kind of going a bit over my head right now because, yeah, I'm still trying to think about this one. And okay, I will okay, I might need to see some existing stuff. Okay. Okay. Oh, it might be the unzipped one. Kind of confused that one. Okay, image. Okay, yeah, it just prints this, And then yeah, you remember the picture generator you wrote earlier. Let's write another one, but this time it will return on an implementation of image instead of a slash of data. Define your own image type, implement the necessary methods, and call pick the show image. I am skipping the exercises from now on because I am a bit tired at this point. Actually, this is, yeah, go routines. Yeah, it's just this is defined as a lightweight thread managed by the Go runtime, so you can run something at the same time. Go routines run in the same address space, so access to shared memory must be synchronized. And the sync package provides useful primitives, although you won't need them much in the Go as there are other primitives. Let's see what are those. Channels. Channels are the type conduit to which you can send and receive values with the channel operator. So yeah, this is like, the async await patterns in other programming languages. It seems like you can create a Go routine here and then create a Go routine here and use a channel as its end result, and then we can await the channel. Okay. Okay, yeah, I might need to replace this audio interface soon. It has malfunctioned 3 times in this stream. Great job, I guess. I really need to replace it soon. Yeah, it has been malfunctioned for a total of 3 times, and that is not a pleasant experience. Okay, let's next this one. Range and close. Okay, you can close a channel to indicate that no more values will be sent. Receiver can test whether a channel has been closed by assigning a second parameter to the received expression. So yeah, you can, like, using the range function, you can like receive everything from this function until it is closed. Okay, really? Yes. It actually malfunctioned at around 20 minutes into the stream, and also at the beginning of the stream. Really fun. Yes, I am troubleshooting it because it does not usually happen on my previous streams. Like on the first and second week, it does not happen, but it only happened recently. Okay, let's continue this one. The select statement lets a Go routine wait on multiple communication operations. A select blocks until one of its cases can run, and then it executes that case. It chooses a one at random if multiple are ready. Whoa. Wow, okay. This is actually really interesting. Like, yeah, you can make a separate go routine and then just make it wait for and then make it wait for new things to come. Yeah, like, okay, to make this simple, like, let's see at this main function. This coroutine just receives the values from this channel, and it will block until a new value is able to be printed. And then this will actually wait until it can actually place something in the channel. So for example, this is the new channel, and then this is the go function. This will wait until a new one comes. I call this go root. I call this function, and then it loops. And when I can put, okay, so this is waiting for value. The channel is currently empty, and then in this loop, I insert a value into the channel. The channel is currently empty. I insert this. The channel is now full. Okay, if it loops again, the channel is full. I cannot insert anything into this, so the select will wait until I can actually insert something into here. And then when the go routine gets the value of C here, it's able to get it and print. Channel becomes empty. Then finally it can run. This can run. And then that loops continuously until this has concluded. 10 loops are done, and then it sends a quit message here. So yeah, we are at the position where the C is now full, but it is not taking any more values. But then it sends a quit, something to quit, and then it gets, oh, the channel is full. We can take something from it, and then it runs this case, and then it quits. Pretty nice. And then there's a default case. It's run if no other case is ready, so you can loop like that. Take, boom. Yeah. Exercise equivalent binary trees. You are going to, yeah. This tour is straight up going to computer science territory right now. A function to check whether two binary trees store the same sequence is quite complex in most languages. We will use concurrency and channels to write a simple solution. Okay, yeah. Yeah, I am not implementing this. And then this is, yeah, mutex. They actually provide the mutex type here. And how do you use it? It's probably just like usual mutex. I'm not going to go into really deep here because yeah, I still have a hard time understanding to how to actually use the mutex here. But yeah, just so you know, it exists in Go. Okay, yeah. That is really fast. So yeah, I will repeat. I will repeat from the beginning again. Thank you so much. That is like the quickest crash that happened. You can get started by installing Go. Once you have Go installed, the Go documentation is a great place to continue. It contains references, tutorials, videos, and more. To learn how to organize and work with Go code with how to write Go code, okay? If you need help with the standard library, see the package reference. For help with the language itself, you might be surprised to see the language spec itself is quite readable. To further explore Go's concurrency model, go watch Go concurrency patterns and advanced Go concurrency patterns, and read the shared memory by communicating code wall. To get started writing web applications, which is a use case that I mentioned at the beginning of the stream, watch a simple programming environment and read the writing web applications tutorial. The first class function in Go code wall gives an interesting perspective on Go's function types. The Go block, the Go block has a large archive of informative Go articles. Visit golang.org for more. And then yeah, we have finally concluded the tour of Go, although with a lot of difficulties along the way, but it is finally done. So what do I do now? Yeah, okay. Let's go back to that particular, the particular code, but I actually okay, let me try to navigate with in a way that does not show my history, because there are some information in there that I probably would not want to actually show there. Shall we go? Okay, so this is the this is the something that I wrote. And this is something that I've written using Go, and yeah, it actually uses a lot of libraries along the way, but it does what I want it to do, which is to store images, and it actually has some pretty nice features like automatic like automatic image hash calculation for similarity search. This is a pretty interesting approach that I probably want to cover at another time, but yeah, this has a built-in similarity search function, so this is like really useful for me, so that I don't accidentally upload the same picture twice. So yeah, it's pretty neat. And yeah, image hashing is available in Go thanks to the aforementioned image interface. You can actually get the RGBA function. Hey, you should if you could. I would like to look over it. Okay, this is getting late at night, but TLDR, perceptual hashing. I think the package is called Go Image Hash here that I use in the in the project, and it implements these things: average hashing, difference hashing, and perception hashing. Okay, let me go back to this. Yeah, I think I use. Okay, this is the similarity search. I kind of need to dive to the documentation to actually find this fun stuff, and it's definitely something Yeah, especially for a project like this. Yeah, you sometimes need to dive deep into the code to actually figure out what it does. So yeah, but okay. Where is the upload function? Okay. I think where is the upload function here? This is the similarity search. Oh, okay. I think it's flop roads here. Okay. Oh, I actually implemented it in the router. Not really great. I think I should have refactored this into the blob surface that I use. So, but well, okay. Yeah, I probably want to do this later when and if I actually remember it. But yeah, remind me in the few days to refactor this. And yeah, so yeah, that is the end of the tour of Go stream. And I am switching to the free chat to yeah, just some announcements that I have for today. Okay, what is my yeah, okay. Yep, okay. That's it. So yeah, tomorrow yeah, this week is quite packed. I actually stream for 7 days a week. I talked about it in the beginning of the stream. So yeah, today is the technology dive stream and also the first anniversary of my VTuber project here. So yeah, thank you for staying with me for yeah. It's only 1 month, but I'm glad that at least some people watch my content here. Yeah, and then tomorrow, yeah, the next 2 days will be games. Tomorrow will be punishing Grey Raven. Too bad to be the streamer. But yeah, Bunny Bunch. Too bad to be the streamer. Yes, yeah, yeah. Thank you. Okay, and then tomorrow, yeah, punishing Grey Raven. And then the next day will be Art Nights, which I am actually I got this idea. Okay, so yeah, gaming. I don't hear you. Yeah. Okay. There was a problem. Well, hacking happening. Yeah, yeah, it's now getting frequent. Yeah, I switched the ports, and let's see if this kind of fix the problem. Okay, so yeah, I will be repeating what I am going to say today. So yeah, this week will be like this. Like I will be streaming for 7 days a week. So today is starting from today, it's the technology dive that you just watched. And then tomorrow for the next 2 days will be gaming streams. Tomorrow is punishing Grey Raven. And then the next day after that will be Art Nights, in which I actually named it very interestingly Operation Flag Seal. Yeah, you know the reference. I watched too much of those ads lately, so yeah, I decided to name it that. Okay, yeah. And then the next one is Windows 7. Operation what? Lol. Yeah, Operation Flag Seal. Probably what I'm going to do in that stream is trying to do a RIS 18 without leaking the Madra Colossus. Seals all the cracks just fine. And that's why I am naming it Operation Flag Seal as a as a joke on the operation name is actually Lead Seal, but yeah, I just kind of inspired because I watched too much of Flag Seal ads. Flex tape Flex tape is Flex tape is probably the most famous commercial, with the energy of I saw this boat in half energy. But yeah, it's actually the Flexil family of products. There's a lot of products there. Let's this turn into a marketing stream. They do collab, dang. No. This is just me getting clever with the naming. I am not sponsored by Flexil, sorry. But if, it would be nice, but sorry, I don't. That's a lot of damage. That might apply to the audio interface just now, with its crashing multiple times. But yeah, that's a lot of damage. And then after that, I will be streaming Windows 7 because July 22nd is the RTM release date of Windows 7, so on that date I will be streaming Windows 7 installation and trying out the operating system itself. Who else still use Windows 7 here? I'm quite curious because Windows 7 has been out of support for 1 year now. And it will be interesting to see people who still stays on that now 11 years old piece of software. And then after the Windows 7 stream, I am going to play Azure Lane. Why? The Idolmaster collaboration is pulling me back into the game. So yeah, I will be streaming Azure Lane after the Windows 7. And then the usual Visual 3 stream, the Visual a week. I will be continuing this service of stream every week on Saturday. So if you want to watch gems, that is the place to be. And then finally, on Sunday, which is not a day that I usually stream if you know me, I will be doing a stream. And that stream is Genshin Impact. And interestingly, I just discovered on stream that yeah, the Inazuma update will be coming just 4 days before the Genshin Impact stream that I'm planning to do. So yeah, guess I will be also be exploring Inazuma on that stream too, on the next Sunday stream. And then just as a preview of what I'm going to review next month, there is apparently a new Toho rhythm game. If you have never heard of it, it's called Toho Danmaku Kagura, and it has a lot of songs from famous Toho circles. I will be playing it on the release date as part of the release radar series of streams. So yeah, it will be the first rhythm game stream that I do on this channel, and which is actually like one of my main interests, but I admittedly have not been talking and diving deep into it as much as I do before, but yeah. So yeah, that's it for today. Yeah, thank you everyone for watching this stream, this quite scuffed stream, but I'm keeping the archive up because it's not scuffed enough. And yeah, have a nice day everyone. I'm ending the stream now.